Welcome to Nanohmics. We are developing enhanced target detection for ISR and counter-UAS missions by developing a spectral imager for the long-wave infrared spectral band. The idea is to improve detection of low-signature targets in clutter using an agile, tunable long-wave IR filter that converts standard infrared cameras into a spectral camera. Nanohmics is a small business located in Austin, Texas. We have approximately 45 technical staff. Most of our employees have PhDs or master's degrees or bachelor's degrees in technical fields. Our areas of R&D focus include electro-optics, metamaterials, microfabrication, computational imaging, and it includes prototyping and low-volume manufacturing. Identification and tracking of hard-to-detect targets that, for example, are in cluttered environments is a difficult challenge. The spectral imager being developed by Nanohmics, based on a tunable notch filter, allows for detection of low signature targets by looking at the spectral signatures of different materials, which makes it easier, for example, to see the difference between naturally occurring and artificially made materials. The imager will be compact, battery-powered, low swap, and able to be integrated in small UAVs. Infrared spectral imaging allows for more accurate identification and recognition of targets. By analyzing the spectral information, which is available in real time, different objects, materials, and types of targets can be recognized and tracked. Nanohmics' compact hyperspectral imager is based on a tunable metasurface made of nanopattern graphene. Graphene is a semi-metal material. In other words, its conductivity changes readily with an applied electric field. The tunable notch filter being developed by Nanohmics uses nanopattern graphene as a tunable notch filter. Plasmonic resonance in the nanopattern graphene reflects a particular narrow band of wavelengths. By applying an electric tuning field to the metasurface, this notch can be tuned throughout the long-wave infrared region from 8 to 12 microns. Using an off-the-shelf infrared camera combined with the tunable notch filter, spectral data can be rapidly sensed and processed to create spectral images of potential targets and other objects. With no moving parts, the tunable notch filter and the hyperspectral imager are compact, rugged, vibration insensitive, and easily integrated into mobile platforms such as UAVs. Nanohmics' spectral imager based on a tunable metasurface notch filter is currently at TRL 3. Graphene is a fairly new material, and its incorporation into tunable optics requires the tackling of several different challenges. Nanopatterning graphene requires handling graphene, which can reduce its electrical features, such as carrier mobility. Nanomics has developed processes for handling the graphene and nanopatterning it. We expect to have tunable metasurfaces ready for the prototype spectral imager by the end of the phase 2 in 2024, reaching TRL 4 or 5. Nanomics spectral imager based on a tunable metasurface has many advantages as well as some disadvantages when compared to other spectral imagers. The only disadvantage is that it uses temporal tuning, which can lead to artifacts in some cases. However, its advantages far outweigh its disadvantages. Its dual mode operation means that an infrared camera can still operate in broadband or can be rapidly switched to hyperspectral mode. This approach also leverages existing IR camera technology. It provides full frame data collection with high signal-to-noise ratio. Spectral data is spatially centered by spectra. Nanomics is also fielding a chip approach to spectral imaging, which has none of the temporal scanning artifacts that might occur in other types of technologies. This technology has been operated successfully at the International Space Station. Other types of spectral imagers can be bulky, slow, low resolution, and many of them have artifacts in which spectral, spatial, and temporal data are not properly aligned. For technology transition, Nanomics plans to leverage its already strong relationships with ISR and UAS primes. Nanomics has experience fielding recently developed technology, including in air vehicles. Our strategy is to integrate and demonstrate the tunable notch filter spectral imager with existing ISR turret systems. The airborne ISR market is estimated to be over $12 billion by 2026, growing at a rapid rate of 5.1%. Other markets and applications include agriculture, pharmaceuticals, food testing, and medical diagnostics. Currently, Nanomics is developing the spectral imager under a Navy SBIR Phase 2 program, which is roughly in mid-Phase 2 as of early 2023. Nanomics has begun to engage potential transition partners and expects to, after delivering the Phase 2 prototype, continue to develop it for integration for field testing to increase TRL. Nanomics has a proven track record for developing and fielding new technologies for DoD applications. Nanomics has a variety of licensing and partnering models to follow, including several recent examples shown here. In addition to the spectral imaging technology, Nanomics is developing a number of novel technologies ready for transition. Examples include a wearable thermoelectric cooling technology, passive wavefront correction, and laser threat warning systems. Thank you for your interest in Nanomics and our compact low swap spectral imaging technology.